Hi everyone, today in Integrated Math 2 we're going to go over Chapter 9, Lesson 5. Here are your objectives. Make sure you write them down in your notes. Alright, so let's go over theorems for special segments of similar triangles. Our first theorem we have is if two triangles are similar, the lanes of the corresponding altitudes are proportional to the lanes of the corresponding sides. So in our case, we have triangle ABC, which is similar to triangle FGH. Remember, this symbol here means similar. When we're talking about altitude, it is a line segment through a vertex and perpendicular to a line containing the base. So in our case, our vertex is going to be A, and our base is going to be that CD, and it's showing that it's perpendicular here with that 90 degrees because that's what's special there. And they both have this. So remember, it says if we have similar triangles, they have corresponding altitudes, so that are proportional. So AD would be proportional to FJ, which would be equal to the corresponding sides. In our case, AB would be corresponding with FG. Alright, our next theorem here says if two triangles are similar, the lanes of the corresponding angle bisectors are proportional to the lanes of the corresponding sides. Here we have angle bisectors. So angle bisectors, let's say if we have a 60-degree angle here. This whole thing is 60 degrees. And I say I need to bisect this angle. Well, if that is bisected, that means I need to split it evenly. Perfect. I need to split it evenly with my new angle that I have. So this would be split in half. In order to find this, you need to divide your number, your angle, by 2. 60 divided by 2 would be 30 for each of the degrees of the new angles. 30 plus 30 is 60 degrees. Alright, so in our example here, it says if triangle KLM was similar to triangle QRS, then we would have our corresponding angle bisectors. In this case, LP would have to be proportional to RT. And then it says corresponding to corresponding sides. So equal to LM, which is proportional to RS. If two triangles are similar, the lanes of the corresponding medians are proportional to the lanes of the corresponding sides. So when we're talking about medians, let's say this has a length of 10. And I'm trying to find the median, which sounds like middle. So our middle point with 10 would have to be 5 and 5 if we split them evenly, which would mean that this side would be congruent to this side as well. Because then they get that line segment gets split evenly to find when finding your median. So in our example here, we have triangle ABC is similar to triangle WXY. If we know that, and we're dealing with medians, we can also say that CD is proportional to YZ, which would be equal to the corresponding sides AB proportional to WX. And last but not least, we have triangle angle bisector theorem. An angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. So if we're given segment JM is an angle bisector for triangle JKL, then we can say that KM is proportional to ML or LM, which is equal to KJ and is also proportional to LJ. Notice it says segments with the vertex K, so K's with K's, L's with L's. And there we go.